Thank you. So I'm going to share my screen. I don't want to say very much about Dymax because we don't have a lot of time. I do want to thank Liz and Alexis in particular, and the rest of members of the organizing committee and the sponsoring organizations. I think this has been a fascinating workshop. I'm sorry I couldn't be there in person. At least I understand the croissants were very good and the coffee as well. But seriously, from what I heard and saw, it was fascinating. It opens up all kinds of issues for us to discuss. We at Dymax have been trying to do similar multidisciplinary things from before they were popular. We were founded in 1989 as an American National Science Foundation Science and Technology Center. It's a partnership among a variety of universities and companies. We have about 300 affiliated scientists. We run workshops and special years and special multiple year programs and research projects, and all really at multidisciplinary types of topics. I invite you to visit the Dymax website. I invite you to make suggestions for workshops and activities like the one we're having now, which I think can really make a difference. And please get in touch. Now, if I may, I'm going to share my screen. So I just made a few notes as I was listening, and then last night, and then a little bit while things were going on this morning. Just a few things for you to think about, or at least the things I was hit with from what I heard. First, about gradations of human-machine collaboration. So there are more variations than simply either it's 100% human or 100% machine. And of course, humans and machines have complementary skills. There are things we want to let a machine do. We wanted to clean up nuclear waste. Chernobyl was an early example where we sent robots in to do it. As it turned out, they could even robots melted down and couldn't stay very long. Bomb disposal work, searching under a collapsed building, or cleaning up the waste during COVID in a hospital room. But machines cannot do that completely autonomously. Humans need to control certain aspects of it. And that's something that counters a popular view that machines, or robots in particular, are going to be completely autonomous. Now, more on this idea. So this ubiquitous idea that a robot is walking around fully self-contained, carrying with it all that it needs to operate in its memory and its power systems and its sensors and so on. That's just not true. And at some point, there's going to be a human in the background. And we've heard that with autonomous driving, we've come to the conclusion that there should be a human on standby. Now, that human can monitor multiple machines and called upon only if something is needed, but it's not totally autonomous. So those gradations are one of the messages I got out of this workshop. There are going to be some applications, however, where you have to let humans keep them out of the final decision, because decision has to be made so fast that there is no alternative. And the power grid, I think, is a good example of where we're going to have to do that. On the other hand, questions arise about when you can trust a human to override a machine and a machine decision. And how can you tell that humans know enough to do that? How do they know more than a machine? How can you tell? And should human control be over the outcome only, or over the process, or both? So those are some of the things I heard about gradations. Some of the things I heard about restrictions on human-machine collaboration I thought were interesting too. Can you tell whether a situation is novel or whether we've seen it before. We'd be more comfortable trusting machine to make decisions if they've seen that situation before. Can you tell whether it's a risky situation, in which case maybe we won't trust a machine as much? So driving on a snowy highway is a good example of one where, well, we've seen highways before, but maybe we haven't seen snow before. So it's both novel and risky. And now you'd be more likely to want human intervention. Next idea is there are cases where we are already pretty sure that machines will do a much better job than a human. And that is certainly true in certain aspects of robotic surgery. But here's a case where there are restrictions. We don't have the allowable rules and regulations to allow machines to operate on their own yet. Also, machines can make mistakes. We don't understand the liability principles that will underlie how we adjudicate mistakes. Who's responsible? Is it the machine owner, the machine manufacturer, the person operating the machine and collaborating with the machine? And can we allow machines to be used if liability issues have not been settled? So I'm asking a lot of questions. Here are a few more that arose from my listening to all these fascinating talks. What are people worrying about when it comes to working in collaboration with machines? Of course, for a long time, people have worried about automation and loss of jobs. But what about conflict over resources? Limited resources in the workplace? If we need more resources for machines, does that mean people will get fewer resources? Of course, we worry when machines make decisions and they're not transparent. We worry about automated decision-making when machines might be biased and things of that sort. It's well recognized that machines can face uncertainty when they have to make decisions. For instance, when there's massive, missing or damaged data. But what is not quite as often discussed is the fact that humans also face uncertainty. And how do you balance off machine uncertainty versus human uncertainty? Why else are people worried about machines? Well, I think people somehow, a lot of people have an algorithm aversion. And maybe that's because algorithms are designed by third-party researchers who may not understand the user's needs and values. And how do we overcome that? And as I said, machines can make mistakes. People worry about liability. And the example of doctors using machines to identify breast tumors is a perfect example here that was discussed. And maybe a question that arose that I think is worth thinking about. People might even worry that a machine can make a mistake on purpose. This goes back to the viewing of a machine being completely autonomous. Is that possible? Can a machine make a mistake on purpose? Maybe that is a science fiction question, but maybe it isn't. So maybe in closing, let me talk about opportunities for people who work machines, but also possible problems. Of course, we know the machines are good at doing the boring, repetitive jobs that might free up human beings to do more creative ones. That's important. What is maybe not as well discussed are issues about people's self-image and people's sense of self and how working alongside a robot might affect those things. And similarly, how does working in a human-machine team affect human dignity, defined in various ways? Can human-machine collaboration in creative tasks like fashion design make humans more creative? And can companion robots working with a person actually improve a person's mental health and self-image? And how do we empower different stakeholders in those human-machine teams? How do we decide which stakeholders have a say and how much power different stakeholders have? And can better methods of performance evaluation enhance human-machine collaboration? How do we measure that performance, keeping human-machine collaboration in mind? And it was discussion about trust in machines, humans trusting machines. Will that trust improve if we have better human-machine alignment? And if we have better confidence in machine accuracy and fairness and so on? And finally, what human characteristics can help us in human-machine collaboration? Are they competence, confidence, credentials, workload? What are those things that might help in the collaboration about humans? And in closing comment of what I've heard here, and you can see I've heard a lot, we know that human-machine relationships can evolve over time in collaborations. But how can we ensure that evolution benefits the human partner? I think that's a major challenge for us as we have humans collaborating with machines. And I think it's a major set of questions, that one and the variety of ones I've brought onto the screen here, that it would be great if some of us could get together and continue the dialogue about. So I'll turn it back to Liz, I guess. And I thank you all for giving me the opportunity to give you a few of my thoughts at the end of the meeting.